We are still on the experiment on bending moment. Before now, we showed how to do what? Get all these values we have here, and we discussed a lot of things concerning this. Okay? And now we said we want to see how to plot the graphs. Okay? First thing you do when you want to plot your graph is to write the title. What is the title? A graph of y in meter against capital M in kg. You assign the unit to it. Then you write the date of the experiment. Today's date is 27th 6 2028. So you put the date of your experiment. I just put any date I want. Put the date of that experiment, very important, and put the title of the graph. Then the next thing you have to do is to draw your Cartesian axis and label it appropriately. I label it. It's already drawn. So when you put your ruler, you draw it. Put your ruler, you draw it, you label it. How do I label it? I call here my y, the unit is in meter, and I will call here my mass, the unit is in kg. Can you see it? Now, next is for us to what? See how to get locate these points. For the one of mass, the instruction plot the graph of y against m. They did not tell us start from the origin or not to start from origin. So where you want to start, you start. I will start from the origin 0, what? 0. So for the mass, I will just say 0.10, 0.20, 0.30, 0.40, 0.50. Then for the y, you see what I will do there. Remember, we have posted how to choose appropriate scale. You watch it on our channel. We have 2 channels. The first one is Chidon's Daniel. When you type Chidon's Daniel, how to choose what? Appropriate scales, you will see video on it. How to get error in slope. You see about 500 videos we have uploaded on this channel. And so for this one, we are still building this channel up to see that we upload as many videos as possible as well. So we have this channel as the first channel, and the next one is the Chidon's Academy Practical. So please just do well, help our channel to grow by clicking subscribe to them, because we'll be uploading a lot of things in these 2 channels. Okay, you are seeing one of those things we are discussing. We'll discuss a lot of things there. Okay, so as you help us by clicking subscribe, share our videos, like our video, comments and all have you, we appreciate, we deeply appreciate. Thank you. And so for us to get this now, for us to see what we do there, what I will do is that I will pick the highest 0.33 minus it with the lowest 0.07 divided by how many buses do I have? 1, 2, 3, 4, 5, 6, 7 divided by 7. Once I do this, I use my calculator. 0.33 minus 0.07 divided by 7. That will be giving me 0.037 and others. And so I have to approximate this, but for me to approximate it, I have to ask, the highest is 0.33, right? And so if I'm using 0.33, I will ask myself, If I'm taking 0.04, 0.04 times 1, 2, 3, 4, 5, 6, 7. 0.04 times 7, what will it give me? 0.28. It will not give me 0.33. And so I can say, let me approximate this to 0.05. Because if I say 0.05 times 7, it will be giving me 0.35. 0.35. So it will go well. Oh yeah. Now here is 0.05, 0.10, 0.15, 0.20, 0.25, 0.30 continues. So we have succeeded to do what? To locate our scales appropriately. Next thing is we locate 0.07 against 0.1. Please, this is just a sketch of the graph. You have to plot your own and use the comment box to tell me what you get. This is just a sketch. 0.1 against 0.33. So this is 0.30, this is 0.35. So about in between is how we will get it. Okay? Then 0.13 against 0.20. You will be having 0.13 against 0. Wow. 0.07 against 0.1. Look at 0.07 about here. This is 0.5. This is 0.5. So 0.07 will be in between. In between. Yes. Please, what we wrote here is oversized. It's a mistake by me. Okay? Just take note of it. 0.13 against 0.2. 0.13 should be about here. 0.20 against 0.30. 0.20 against 0.30. Please use your graph sheet to do this location well. Then 0.40 and 0.26. So 0.26 will be somewhere here. 0.50 is against 0.33. It should be somewhere here. Okay? So once you finish locating your points, next thing is you place your ruler. You place this your ruler and locate your line of best fit. So we have succeeded to locate our line of best fit. Now the next thing is to get our what? Slope. If you notice in this line of best fit, every point did not enter, but it is drawn such that if some are to fall out, the one that will fall out in one side will be equal to the one that will fall out on the other side, or only one will fall out. If only one fall out, no problem. But if two are to fall out, one will fall in one side and one will fall in the other side. If it is three that will fall out, you see it will be an issue because two will be on one side, one on the other side, and it's not a good line of best fit. So you have to redraw it if you have such case. You have to redraw it. But as it is like this, it is okay. It is manageable. Okay. Now let's get our word slope. You get your word. You take this down. You take it down with your ruler. Then you take this one also with your ruler. This is called change in y. Why this is called change in m. Now, what you now do is, this is 0.33. You say 0.33 minus this one is 0.05. Then for this horizontal, this is 0.50 minus here it is in between. So 0. Here is 0.05. In between 0 and 0.1 is 0.05. 0.05. And so you have to what? Do your slope. And so you have to say that your slope is equals to change in y all over change in m. What is your change in y? 0.33 minus 0.05. What is change in m? 0.50 minus 0.05. Then you use your calculator to do it. 0.33 minus 0.05 divided by bracket 0.5 minus 0.05. So you will be having 0.62 approximately meter per what? Kilogram. Because unit of y is in meter, unit of m is in kilogram. That is how we got our unit. This unit is very important. All these units you see me applying here or putting here, they are very important. They are very important. If you want to show you are a physics student, it's very important. Now we have gotten our slope. Then they said we should find the error in what? Slope. There are many ways of finding error in slope. One of the ways you can use to find the error in slope is you have to call this line slope of best fit. So you have to get the slope of worst fit. How do you get the slope of worst fit? This method of finding error in slope, that is use of slope of best fit minus slope of worst fit to get the modulus of it. It is one method. Another method is use of vertical scatter principle. And all these methods I discuss in that my first channel, Chidon's Daniel. Just type Chidon's Daniel, how to find error in slope. You see how I discuss all the possible ways or some of the possible ways you can use to do that. Okay? And so as you see this, I want to use principle of best fit minus worst fit to get it in this video. To use that principle, I have to find the mean of mass and the mean of y. Let's get the mean. 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 divided by 5. I added everything here, divided by 5, it gave me 0.3. I note it. I will also add the one of y, 0.07 plus 0.13 plus 0.20 plus 0.26 plus 0.33 divided by 5. Now for this y own, I also have it to be 0.198. And so this mean of mass, I will locate it. And the mean of what? This y, this is 0.198. That is the mean. I will locate them on the graph. 0.198 is almost here. It is at this line of best fit. That means since it falls at this line of best fit, here is 0.20, 0.198 is close to 0.20. That is why I locate it on the. So that means this line of best fit is perfect because it passed through the mean of mass and the mean of y. That is one of the intrinsic property of line of best fit. It must pass through the mean of the y values and through the mean of the x values. Okay? And so what I will do to get my slope of worst fit, to get my slope of worst fit, I will take one of those points that fall out. I am taking this point that fall out to connect it with the what? That mean of mass and mean of y where they intersect. It will pass through it. We call that mean of mass and mean of y, we call where they intersect the centroid. We call it the centroid. Okay, so we put our ruler. When we put our ruler and balance it well, so we will now say this is going well. And so look at the one of line of worst fit. Look at it. It's passing through that what? Centroid. It's passing through the centroid and through this point. Please, you just use your graph to do this plot so that you get the accurate answers. And so what we will do now is we'll get the mean of this line of worst fit. I can start from here. To get the mean, I can start from here. I've drawn it to this point. I will also draw this one. To this point. This is changing m and this is changing y. Now for this one, in between this and this, you have 0.275. You say here 0.275 minus you take it here 0.1. You note it. Then for horizontal, here is 0.40 minus, what about here? Here is, since here is 0.10 and here is 0.20, here will be about 0.40, 0.14. Here will be about, since it's not up to the middle, 0.14. We say 0.14. Since here is 0.10 and here is 0, so since here is not up to the middle, we say 0.14. We say worst fit slope is equal to change in y all over change in m, and is equal to 0.273 minus 275 minus 0.10 all over 0.40 minus 0.14. That is slope of worst fit. but this is your actual slope, that is slope of best fit. Okay, and so you still use your calculator to check what it will give you. You will be having 0.275 minus 0.1 divided bracket 0.4 minus 0.14. That will be giving you 0.673 meter per watt kilogram. That is slope of worst fit. And so your error in slope, error will be equal to modulus of the best fit zone minus the worst fit zone. Best fit zone minus worst fit zone, or worst fit zone minus best fit zone. Anyone can go first. Modulus mean if you get negative, forget about the negative. If you get positive, take the positive. So we say 0.62 minus 0.673. What will it give you? Modulus of it is 0.053. So that is the error in the word slope. That means I will package my slope this way. Slope equals to, what is the actual slope? 0.62 plus or minus 0.053. I'll bracket it like this. I will say it is meter per watt kilogram. So if you want to package your slope well, it says slope equals to the actual slope plus or minus 0.053 meter per watt kilogram. That means your slope falls in this word range. Either it is 0.62 or it is 0.62 plus 0.053, or it is 0.62 minus 0.053. But if you have it like this, whichever or whatever is the marking script, it will fall in that word range of values that will be given to them. We have been able to get the slope, the error in the slope. Now they say deduce the Young modulus E of the meter rule. When we are able to deduce it, that will tell you quantitatively, in quantity, how stiff or how flexible the meter rule is. Okay, to do that, recall that the formula Y is equals to mgl cube all over 4ebd cube, where g acceleration due to gravity, L is the length, where our length L is equal to 0.75 meter. The length from here to here, 0. And our g, we took it to be 9.8. Acceleration due to what? Gravity, meter per second squared. Then our b is equal to 0.025 meters. Then our d, the thickness, is 0.005 meters. And we are to deduce the E. Rewriting this formula, it implies that if y come down, if m come down here, it becomes y over m. And y over m is graph of y against m. That is the slope. If this come down, we have y over m, which is equal to the slope, because we say change in y all over change in m. So that means the slope is equals to gl cube all over 4ebd cube. Now, making it subject of formula, which is Young modulus, we will bring it up, and therefore E will be equal to gl cube all over slope times 4 times bd cube. So we put our parameters accordingly. Our Young modulus will be equals to what is our G? 9.8 times 0.75 cube. This 0.75 is what we got from our measurement. Then all over the slope is what? 0.62 times 4 times 0.025 times 0.005 raised to the power of 3. So you use a sound calculator, so do it. You say 9.8 times 0.75 cube divided by bracket 0.62 times 4 times 0.025 times 0.005 raised to the power of 3. And so that will be giving you 1, 2, 3, 4, 5, 6, 7. That will be giving you 0.53 times 10 raised to the power of 9 Newton per meter squared. So in the starting part of this video, we say let our A be 0.5. But why doing everything, we are now getting 0.53 times 10 raised to the power of 9. So that is how to solve or to perform experiments on Young modulus of a meter rule using bending moment method without using calculator. That means quantitatively, how stiff or how flexible the meter rule is equivalent to 0.53 times 10 raised to the power of 9 Newton meter square. If someone want to convert it to dyne per centimeter, we say that Newton per meter square is equals to 10 dyne per cm squared. And so I have to multiply this by 10, or it is equals to 5.3 times 10 raised to the power of 9 dyne per cm squared. Okay? So that's how to perform it. If you enjoyed this video, feel free to click subscribe so as to promote our channel. Also share to your friends, to your classmates, like the video and comment. Okay? We'll post more videos on physics practical experiments. Thanks for watching the video.